Hello everyone, my name is D. Shranjyoti. My roll number is 24BQ1A0426. I am the ECA A section student. I am take the subject of switching theory and logic design. This subject I give the I will give the seminar about Boolean logic functions. Boolean logic functions. In this Boolean logic functions, Boolean function representation. A Boolean expression is an expression which consists of variables, constants and logic operators which results in true or false. In this means true represents the 1 and false represents the 0. I'm again repeat this. 0 represents the false. We will assume that 0 represents the false and 1 represents the true. Boolean functions is an algebraic form. That means we will n number of variables are taken. That means represented by f of x1, x2, and so on xn. We will take any number of representation of Boolean functions. This is infinite. By using Boolean laws and theorems, we can simplify the Boolean functions in digital circuits. We will simplify the Boolean functions. In this topic, we will discuss the two types of Boolean Boolean functions. Canonical form. One is canonical form. Second one is standard form. Canonical form is again divided into two types. Sum of minterms or canonical SOP. Product of maxterms or canonical POS. Standard form is again divided into two types. SOP form, POS form. SOP means sum of products, POS means product of sums. In this canonical form, we will see this canonical form definition. Any Boolean function that is expressed as a sum of minterms or product of maxterms. In this definition, this is called canonical form. And extra definition is each term contains a Boolean variable of the function. This canonical form, each term contains a Boolean variable. It means involve two Boolean terms. One is minterm, second one is maxterm. Minterm is the product terms of n variables. This minterms form the product of n variables, in which variables will appear once either in its complement or uncomplement. Complement means complement is means A complement, B complement, C complement. That means not gate. That is the uncomplement or complement. Sorry, complement. Or uncomplement means complement opposite. That's the minterms definition. And this minterms range is 0 less than or equals to I less than 2 power n. Anyway, this one main point is there in minterms. First is a variable is a complement form if its value is assigned to 0. This means that variable contain a complement form. This complement is assigned 0 and that variable contain uncomplement form. This is the assigned to 1. So we will see this minterms. The canonical form is again two types. First one is sum of minterms. We will discuss this sum of minterms. Any Boolean functions can express it as the sum or of its minterms. I am say this definition again. Any Boolean functions can be expressed as the sum or of its minterms. This represented equation will be, see this notation, f of list of variables. We will take x1, x2, x3 and so on xn. Up to n values we will take the list of variables. And sum of minterms we will represent the summation of list of 1 minterms indices. See this example. We will take only 3 variables, not 3 literals. We will take w, x, y, z, u, v. We will take number of literals. For example, we will see this f of x comma y comma z is equals to, we will represent the summation of 3 comma 5 comma 7 Except this 3 comma 5 comma 7, we will represent the sum of minterms. Example of canonical form sum of products expression. Minterms form, see this xy. Xy means this was x is uncomplement, y is uncomplement. This means xy g 1 1. X bar means complement. X bar means complement. Complement means 0. Y uncomplement 1. In this way we will represent the sum of minterms 0 1. And second one is max terms. Max terms is defined as sum of n variables within this range 0 less than or equals to I less than 2 power n. The max terms of is denoted as capital M. See this minterms, we will represent the small mi. This max terms we will represent the capital Mi. See this two variables Boolean function possible max terms are x plus, see this minterms in x into y. This means x is the uncomplement, y is the uncomplement. This is 0 1 1. See this max terms. In max terms, each variable is complemented, its value is assigned to 1. That before we will see this minterms, complement value is 0, uncomplement value is 1. This max terms reverse, complement value is 1, uncomplement value is 0. This is the small difference between minterms and max terms. See this product of max terms. Any Boolean function can be expressed the product and, that means and, of its max terms. This represents the equation will be, see this notation, f of list of variables. We can take the number of variables. This product of minterms represents the pi. That before we will see this sum of minterms represents the summation. This product of max terms we will represent the pi of list of 0 max terms indices. That means complement, we will assign the complement is 0. That's why we will take 0 max terms indices. Example, f of x comma y comma z is equals to pi of 0 comma 1 comma 2 comma 4. Example, see these examples. This way we are take the examples. Next, I will form the table like this. The below table will make you understand about the representation of the minterms and max terms of 3 variables. We will discuss before the class. Minterms, complement value assigned to 0, uncomplement value assigned to 1. Max terms, complement value assigned to 1, minterms, uncomplement value assigned to 0. See this table, we will take the numbers 0 to 7. 0 means 0 0 0 1 0 0 1 up to 7 1 1 1. This way we are form the minterms and max terms. Next, conversion of canonical forms. Conversion of canonical forms means convert the sum of minterms to product of max terms or product of max terms to sum of minterms. See this steps. First we have steps. First step is interchanging the operational symbols. Summation means sum of minterms. Pi means product of max terms. This is the summation is given, we will exchange the pi. Pi is given, we will exchange the summation. Second step, writing the indexes of the terms that are not presented in the given form of equations. We will see the SOP form to POS form. SOP form to POS form. To convert the canonical SOP form into canonical POS form, first we should change the summation to pi. This means sigma to pi, we will change the values and then write the numeric indices of missing variables of the given Boolean functions. For example, sum of minterms we will take f of summation a comma b comma c of 0 2 3, except this 0 2 3 4 5 we will represent the f of pi a comma b is same, but 0 2 3 4 5 7 except these numbers we will represent the 0 2 3 4 5 is there, but 1 4 6 is not there. That except this we will represent the 1 4 6 in this way. Same as some conversion of canonical PYS form to canonical SOP form. See this, first interchange the pi to summation. Before we will discuss the sigma to pi. This pi to sigma. See this, f of pi of a comma b comma c 0 3 5. Except this we will represent the is not there numbers, we will take this numbers 0 1 4 6 7. In this way we are convert the canonical forms. Next, second type is standard form. Standard form is mainly divided into two types. We will discuss before topic. First one is sum of product form. Second one is product of sum form. See this sum of product terms. SOP form represents the most suitable to use them. FPGA. FPGA means field programmable gate array. We will see these applications. We will discuss this point. Examples. See these examples: AB plus BC plus CD. It converts into AB whole bar plus ABC plus CDE bar. Product of sum form. This is means this form is exactly opposite to SOP form. So this can also be dual form of SOP form. Example, see this example. We will discuss these examples. Next one is conversion of SOP to PYS. Conversion of SOP to PYS. Example. See this example, convert the SOP function. See this function, we will take this f of xy plus xz plus yz. We will simplify our topic is Boolean function simplification process. This SOP to PYS form we will simplify the Boolean functions. See this function f of f is equals to xy plus xz plus yz. This function we will simplify the Boolean function. See this solution is our function give this function, and we will xy xz yz. In this xy we will miss the z. For Boolean theorems, for z plus z bar is 1. In this way we are taking the x plus z bar, y plus y bar, x plus x bar. In this way we will multiplication, and we will in this way we are this. See this minterms SOP 3 5 6 7. Next, conversion of PYS from to PYS SOP. Example, convert the PYS function. See this f of a bar plus b plus c into b bar plus c plus d bar into a plus b bar plus c bar plus d. This is our function. In the first term, the variable d or d bar is missing to be add. This means d into d bar means 0. In this way we are multiply these variables. See this last pi of a comma b comma c comma d. These numbers we got. Next, applications of Boolean logic functions. In this, see these applications. First one is digital circuit design. First digital circuit design application is very useful for using Boolean logic functions. And we will minimize the circuit minimization. Second one is circuit minimization. Our function is minimization. Circuit minimization is minimize the function. Third one is error detection and correction. Also we will use the application programmable logic design. We will see the SOP, this conversion. Programmable logic device is also used decision making system and database queries. In this way we are solve the applications and all of these. See this switching theory and logic design. My topic is Boolean logic functions. Thank you all.